Welcome to Advanced Insights, where we provide just what the show name suggests. Advanced insights into some of the most exciting trends and topics in technology. I'm Mark Papermaster, CTO and EVP at AMD. On this episode, we look at the computing behind Meta's social media empire. It takes a ton of processing capability to enable 3.2 billion people that engage daily on its applications. I am joined on the show today by Dan Ravinovitz, VP of Infrastructure at Meta. As a quick intro, he leads a team developing and sustaining data center hardware and AI systems. Dan has more than 30 years' experience in developing technology that connects people with a particular focus on market disruption and innovation. Dan has served in executive leadership roles in Silicon Labs, NXP, Atheros, Qualcomm, Ruckus Networks, and of course now at Meta. Very early on in his career, he was a product marketing manager at AMD actually for 7 years. Dan, my fellow University of Texas Longhorn and former AMDer, it is great to have you on the show. You have come a long way since your time at AMD back in the 90s.
Yeah, Mark, we share that great heritage, and honestly, I look back at my AMD days with a lot of fond memories. It was an amazing time to be at the company, and I learned pretty much everything I needed to learn to set out and join startups and do all that after spending so much time with AMD. So great memories for me.
Super. Well, look, I look forward to discussion today. I mean, you look at the kind of infrastructure that you're driving with your team, Dan, at Meta, and it's just, to me, it's just amazing. You guys are serving, 3.2 billion active users a day is the data I have, and with that is a whole infrastructure to serve those customers, but you've also got, a massive internal development. But before you and I dive into technology, I would love to just start with, just your view of the mission at Meta. I mean, social media is just every day playing a bigger role in all of our personal lives and also our work lives. It's sort of the connective tissue in our society. And with, Facebook and Instagram and WhatsApp, maybe we could just start though with social media and the role that you guys play at Meta.
Yeah, I mean, with 3.2 billion people on the platform every single day, and now 500 million active users on Meta AI, you can kind of see the import for people in their daily lives is very obviously there, but the social media experience is constantly evolving. And you can very clearly see that, once content creation became a big thing, then video became dominant. Now, those two things are starting to interact with AI in a more robust way. And, people who may not have had the ability to create content on their own professionally are being able now to take advantage of all the AI tools to generate video, to generate text and images. I think the other thing that's been really interesting is if you look at messaging is one of the harder things to monetize, but it has grown so dramatically. So, I mean, there are 2 billion calls made on WhatsApp every day. I mean, it's certainly, if not larger than the entirety of the telecom industry, it's close. It shows that messaging platform really is critical for connecting billions of people to each other every day. But the monetization of that has not been obvious. But now, for the first time, WhatsApp and Messenger, for example, give you access to free large language models in Llama. So just as easily as you would send a chat message to your friends, you can now, basically make a query. And that more and more, and at least for me personally, is replacing my use of, conventional search because the infrastructure is very reliable and the answers are very good and relevant. So I think that's one of the bigger, changes that we've seen just in the past 12 months.
Well, it's amazing to me because you talk about, Meta AI, and it's like a whole another element that it adds in your role in the infrastructure team at Meta in terms of the kind of compute capability and services you provide. Why don't we tease it apart? So let's first say, even before Meta AI, there was this vast set of services, and as you just said, it's different. I mean, messaging and WhatsApp and the text and voice services there are different than the massive video content that Instagram and Facebook would have. If we just think about that, just externally providing that, it'd be great to share with the listeners what that means. Like, how do you think differently about infrastructure with that kind of worldwide dependency that you have on your services versus someone that's running, a capability for an internal company? Very important, obviously, for that company's operations, but not having those billions of people depending on it. How should our listeners think about what kind of stress or expectation that you all have to think about from infrastructure standpoint?
It's a great question because we're often thrown into the same club as the other hyperscaler companies that you think of, companies like Microsoft and Google and AWS, for example. We're operating at that scale, but we're not a public cloud company. We only serve our users, and we are the infrastructure behind all of these services that you've come to know and love. And I think one of the interesting things about that is we are in a position not only to deeply understand those few customers and their needs and serve them appropriately, but we're, maybe in contrast, we're not in a situation where we have to build generic solutions that would fit any particular workload or application. So there's a certain, luxury and benefit to that, which I think is pretty cool. But I think the other piece of it is we have many, many people depending on these services. And in some cases, if you look at commerce, for example, one of the big trademarks of our company is that we are in a position to help small and medium-sized businesses actually get to very large, sophisticated scale with their advertising, for example. And that also is a huge responsibility. We have, millions of businesses around the world that are also depending on this platform to reach their audience that don't have the benefit of brick and mortar locations. They don't have a large high-touch sales force. And so we have become basically that way of really reaching people who are interested in a product with the people that can provide it, and making sure that those links are actually super relevant so the experience is great. It is a very large responsibility. And Mark, I will tell you, of course, there are days when, we wake up and we are stressed. We want everything to work perfectly. And at this scale, there's a lot of work that goes on behind the scenes every single day to make sure that we're standing up the best services that we can.
Well, I want to circle back to Meta AI because already it was a daunting task. I'm sure you had largely a CPU and networking dominated infrastructure not that many years ago, and now it's vastly more complex because we all know AI has just an insatiable hunger for more computation. And it's a different computation. It's really driving through the very base algorithms of a multiply and accumulate a math operation underneath. So it really lends itself to parallel computation, whether that be in a GPU or a specialized device. So maybe you can share with us, what that's meant and whatever you can share in terms of your infrastructure of, adding GPUs and your thought of, how you accelerate Meta AI.
I think it's no secret we were, a little late to, adopt AI accelerators in the fleet, and but once we got started, we went very, very fast. I think one of the things I love about working at this company is we are still very agile. Despite our size, when the company decides to do something, we can pivot incredibly fast, and the entire company gets on board there. So I think our shift into going full gas on AI systems was extremely successful. I think we were one of the first to deploy, for example, another company's last gen of accelerators at scale. And getting that working properly was very was extremely stressful across every aspect of the work. Designing and developing the racks, the software development, deploying in the data centers, and figuring out how we were going to make that quick and reliable. But all of that last gen was still using kind of conventional technologies, relatively low density racks, air cooling. We didn't have liquid in that time frame. And yet we still encountered incredibly difficult problems that I think are now well published, and I've shared some of the data as well. But if you look at, for example, inference, first of all, that's not where the majority of our spending was in the past, couple of years. And it was relatively lower complexity to get inference running at scale. But training has been an absolute journey that stressed every aspect of our engineering brains. and I think one of the things we learned is that this AI hardware is much more fragile and complex than our kind of older generation of conventional computing that we've come to rely on AMD on for a long time. And so that change prompted a whole bunch of extra effort on our side to basically make it work. Not only were we advancing the analytics work that we normally do on our fleet to get better insights into unplanned unavailability and what was actually happening with these larger training clusters, but we also had to figure out, okay, how do we change our sparing strategies so that we always keep the fleet up and running as much as possible. So it was a huge cycle of learning to get us there. And I will say that the journey is still probably 1% done, Mark. We have so much work ahead of us to make this scale. And the new generation of accelerators that are coming into the fleet are going to now further stress all of the things that we've traditionally been using as our North Star for how to operate a fleet.
You talked, Dan, about infrastructure at scale, and I think our listeners would love to just get a sense of that. I mean, it's not like you can run at one data center. You guys have to have multiple data centers. I mean, the connectivity you have to have must be immense. I mean, I know you can't go into proprietary specifics, but maybe broad strokes. What does it take to support all of these massive platforms for social media?
It's kind of insane, Mark, when you think about it. So there's certain things that are relatively public that you can find on our site. So, for example, we have basically 27 data centers around the world. To augment those, we have also invested in partnerships with colos. We have a number of points of presence around the globe, pretty much edge pops with all of the major telecom service providers everywhere on the planet, so that we can do efficient peering. And we've actually been really huge investors in connectivity. I would say not just the traditional kind, but we're one of the largest deployers of subsea cables on the planet. One of the projects that I was associated with in my prior life was, our project in Africa, where we are literally putting subsea cables all around the continent and then doing massive fiber connections back to other parts of the Middle East and Europe. So, I mean, these kinds of investments in subsea, for example, they're multi-year, they're very expensive, but they're really required if you want to, really make the experience on the platform great. I mean, low latency is, at some point you're just battling the speed of light, and so you need a lot of fiber plant, and you need it everywhere that you have infrastructure in order to make those experiences great. So if you look at that, plus the size of our fleet, I mean, we're in the neighborhood. Let's say we're north of 12 million servers in the fleet today. It's a lot of infrastructure to manage, and we're always trying to balance reliability, extending the life of the servers to be economically responsible to our shareholders, and looking for the right time to upgrade certain parts of the fleet. Another, interesting thing, like we just published news very recently about our new 2 gigawatt plus data center that's going to be in Holly Ridge, Louisiana. If you look at the overlay, and there's some interesting pictures out there, the size of that data center is not that far from the size of the island of Manhattan.
Oh my
God.
It
is massive. Yeah, I mean, Mark, when you look at the overlay, it kind of brings it home how big these investments are. And granted, I mean, we've always built rather large plants, but AI is changing that, and the fact that we're building something that at scale will get to 2 gigawatts of capacity in one location just tells you, how AI is changing this industry. And of course, that also really impacts if you think about some kind of a global issue, we need power, and all of our peers need power, and the entire industry right now is actually limited by the amount of power and electric capacity that we have. So these are very, very new and very interesting problems that we have in the infrastructure world.
I think everyone's waking up to the need of power. Given the growth of AI, it's been in the news lately, and talked about it. On this whole quest for artificial general intelligence. I mean, it just commands more and more computing. And from our part in AMD, and we partner with you deeply on this. We're driving energy efficiency in everything that we can do, and it's been tremendous partnering with the Meta team on that shared objective. In fact, as you well know, you're one of our most demanding customers in terms of maximizing the performance while minimizing the wattage of energy expended. So thanks for driving us hard on that critical metric. Let's map the future here, and you think all your internal demands are growing as you support your internal infrastructure at Meta. And social media is changing. There's new modes going forward. And so I don't see, any relief coming to you and your team in the future. And yet there's probably even new modes of the way that social media is even consumed. And you guys have Meta Quest, which has been growing, and I know you have lots of other projects on your long term R&D. What's your thought when you look forward? What do you tell your teams in terms of infrastructure needs of computing? Is there a different mix that you see of CPUs, GPUs, specialized devices? I know I look at it as sort of a continuum. You've got CPUs that do everything, GPUs accelerate specialized computing like AI, but specialized devices have a key role because they can narrow in. But maybe start with broad brush of where, what you see as demands coming, and then your thoughts of the future of computing devices.
Yeah, this is super exciting. I've spent about half of my career in infrastructure and the other half in consumer electronics, and I spent a very long time in the mobile industry. So one of the things that I think is the most exciting for me, I personally think that Quest is just an amazing product, doing extremely well. I mean, I think if you look at that product, you can very easily see that the extension of something that's more familiar for gaming can easily now project into the business world. But the Meta Ray-Ban glasses for me are the ones that are actually the signal for much larger. I think the total available market for glasses is very, very large. And the experience that I've had personally over the past year using the Meta Ray-Bans is that I put my phone away when I'm using them. And not having that piece of glass in front of me all the time and just being able to use natural language to ask, glasses questions like, what am I looking at? Can you translate this into another language for me? All of that capability now just resting on your face where it's natural. They're lightweight, so you can wear them, for most of the day. I think this is actually the glimpse of the future where the use of AI, access to all of the services, messaging, Instagram, Facebook, taking video, immediately posting it to share with your friends. There's a great use case I love with WhatsApp on the glasses where I can start a call and then I can switch that mode to where I'm now sharing what I am seeing with the person I'm calling. It's such a cool, different experience. And I used it and I was in an airport, calling my wife. I said, "Hey, you got to see what I'm seeing," and switch to that mode. And it's just a very different, very natural experience when you have the device on your face. So I think there's going to be a ton of runway now for glasses, and the better that product becomes, the more styles that we have that fit with a wider range of faces and people's preferences, the more ubiquitous that will become. So I'm particularly excited about that because it's a vehicle that matches the footprint that we have with the rest of the platform.
And you think about that, We've all been saying this for a while. I know it's been a theme of mine. Is that people don't realize that generative AI fundamentally changes the way that we interface with computing. How do you get at computing? Because it used to be the realm of a handful of scientists and supercomputers. Then came the revolution of mobile, and it became available for many of us, but we're still running complex programs. And generative AI reduces it, just as you said. It's the spoken voice. And now, as your point you're making is not only what you ask, but what you see, what you hear. You can have it, with you all the time. And you guys have been driving models to be smaller and smaller. There's a lot of press now with DeepSeek and the advances it's made. But I think about what Meta's been doing with Llama. You've been driving incredible model efficiency, and so there's a lot that you can do without any computing beyond what you have in a device that's almost hidden. It's almost invisible. It looks just no different than our normal apparel, but it can seamlessly tap where you need more computing that might be in a phone or a PC, or right back to the cloud where there is that massive infrastructure building. It's a complete game changer.
It really is. And one of the interesting things that the industry is going to wrestle with over the next 3 years is, what is the edge of the network? And I think this is an interesting thing to talk about. So first of all, I want to reinforce that Meta's commitment to open source is very, very deep. And the fact that we've spent a lot of money and a lot of energy to create these foundation models, but then make them open source, I think is powerful, because nobody else who's using Llama, for example, ever has to go, spend that money, nor consume that electricity to basically get to that, to the utility of the model. So it's enabling lots and lots of people and businesses and government institutions to take advantage of an open source model that will continue to get better over time. And by shrinking that, thinking about that 7 billion parameter model, the fact that it can fit on a very, kind of bog standard consumer electronics device is very powerful, because now the user equipment, your phone, your tablet, your laptop, is actually a very highly functioning inference platform. You don't need to actually run a bunch of that in the data center, which, selfishly, that's awesome because that means we've effectively created a great user experience that's not having to use our data center infrastructure, which is not a bad thing. The question is actually what use cases would precipitate the need for running some of that at, let's say, an edge POP, for example. And I think there's some hypotheses around what would make sense and why. But so far, we haven't actually come up with the strong, absolutely imperative use case. But I think the next 2 to 3 years, we're going to discover all kinds of interesting modalities where a bunch of things can run very comfortably in your kind of collection of consumer devices. Other things clearly need to run in the data center, and there may be use cases that are emerging now where the edge comes in as an assist, basically. But there's some really interesting challenges for that. It's one thing, we're so dependent on the robust reliability of CPUs and bog standard storage, network, and compute hardware that we've been, developing over the many, many years. When that sits in an edge POP, it's so reliable that honestly, maintaining that is really, really easy. The minute that we move AI infrastructure into an edge POP, we need to start thinking about, okay, how can we maintain this? How do we keep the uptime appropriate? How do we deal with sparing and all of those things that are more complex with AI systems? So, I think besides this challenge to get to lower performance per watt and, driving down perf per TCO for AI systems, we have to also have the pendulum swing back to how do we make all these systems as reliable as the beloved, kind of general compute platforms that we've been building with for years? And that is a pretty big challenge for the industry.
We love collaborating with the industry, so this is going to be one that's going to be really fun to take on because it's a must. Look at, as you said, once your lives are completely depending on the computing, and now it stretches from these massive hyperscaler infrastructures like you run right down to the edge, right down to the devices. It has to have that trust of uptime. It has to be available to you. And given that, you talked about, CPUs have been around for decades. We recently celebrated the 50th anniversary of the CPU microprocessor. And so,
Congrats.
what do you think about how that works going forward? CPUs, GPUs, specialized devices. Does one win? Or does it continue to be a need, across the disparate landscape that we see evolving today?
Yeah, we don't see everything converging to AI accelerators. I mean, we need general compute in the fleet, and the vast majority of our fleet continues to be general compute because that's well, a lot of our workloads are running on those platforms. And storage systems are CPU based. I mean, we could go on and on about. I don't think CPUs are going away. I do think that the overall trend, though, is to try to figure out how to make everything more power efficient. I mean, it's not a mystery. Your main source of scarcity right now is power. You want to optimize everything in the data center to consume as little power as possible, including AI accelerators. Today, though, in many ways, we're trying to reduce the power consumption of everything else so that we can make room for our AI accelerators and GPUs to run. But obviously, the best thing would be if all the elements that we have in the data center are becoming more power efficient over time. It's not quite there yet, but that's the direction that we would like to go. I think the other interesting thing is that, and we should keep this in mind, storage systems are going to change. And network topologies are getting more complex, and network interfaces are also just going to ever higher speeds. Everything that is associated with the backend fabric for AI systems is pushing to higher and higher speeds and lower latency for certain kinds of functions. So if you look at that, everything is trending in kind of the wrong direction in terms of power consumption. When you're at 800 gigabits per second for your NIC from 400, it's not like you're getting that for free on power consumption. So there's some really hard problems the industry is facing right now because we're pushing performance so hard. And as we all know, when you do that, in the absence of like a magic pill like what we had with Moore's Law, where, okay, I'll just wait. When we shrink to the next node, I'll get the power back. We're not there. So, in some sense, this is very, I would say, sobering and a bit terrifying for people in the technology world. But constraints are good. In general, anytime we have this kind of constraint, it forces us to go innovate in somewhere, some other location. Like AMD has become a leader in 2.5D and 3D stacking, which is the only logical way you can move when Moore's Law starts to slow down. I think the same thing's going to happen with model evolution. And, the recent innovations that we've seen coming from a company like DeepSeek actually is proof that constraints are good. You get a lot of innovation if you don't have access to the latest and greatest hardware or, the fastest network in the world. And I think all of that is wonderful.
I couldn't agree more, Dan. I use the phrase holistic design. Like it's not anymore just about a compute device. It's about how you optimize it system level, as you said, networking, storage, all the way up through the entire middleware and application stack. I mean, it's going to be incredibly exciting. Dan, I want to wrap up, and I want to say that I look forward to having you back in the show, and we're going to conduct that future show simply wearing glasses, and we're going to ask Meta AI to be the host and to ask you and I questions. So that's going to be our marker for the progress that we're making.
I love it. Yeah, and hopefully by that time we'll have a bunch of cool new features that we can test together.
That'll be awesome. I cannot thank you enough for joining us here and sharing your insights and really just the scope of kind of infrastructure that you and your teams at Meta are putting out every day, and most all of us that are listeners are users. And so we say thank you.
Thank you, Mark. It's such a pleasure to spend time with you today. Thank you.
I truly enjoyed chatting with Dan Rabinovitz. The main takeaways from our discussion are, first of all, the immense scale of AI computing. It's driving Meta to build a new data center that consumes the area of Manhattan. Secondly, the journey to scaling, as Dan described it, is only about 1% done, and it takes a high collaboration culture with a no fault, no blame approach. And then lastly, that new devices will redefine how we access and leverage AI in the future. Thank you for joining us today on Advanced Insights. I look forward to bringing you more in-depth conversations on cutting-edge technology and industry insights and visionary perspectives from some of the brightest minds in the field. You can watch our show on AMD's YouTube channel, or you can listen on Spotify, Amazon Music, and YouTube Music audio-only platforms. Technology is always advancing, and I can't wait to share more insights with you next time.